If you're coming to AI development from JavaScript like I am, the first thing that hits you about Python isn't the syntax, it's the libraries. There are thousands of them. Everybody's import block looks different, and nobody ever stops to explain what any of it actually does. So think of this video as a map. We'll walk through the Python libraries that actually matter for AI engineering, grouped by the job you're trying to do. And for each one, I'll tell you in one line why it won. By the end, you'll open any AI tutorial, read its imports, and know exactly what every line is there for. These are the tools you'll see over and over. But let's start with the most basic job of all, actually talking to a model. Every AI app starts the same way. You send some text to a model, and you get text back. The libraries that do that are the provider's SDKs, and each big model has its own. For Claude, you install Anthropic. For GPT, you install OpenAI. For Gemini, it's Google Gen AI. They all work the same way. You hand them a prompt, they stream back a response. Now, if you think you'll switch models a lot, there's one more worth knowing. Light LLM wraps all of them behind a single interface, so you can swap Claude for GPT without rewriting your code. Here's the thing nobody tells you. A raw model gives you a blob of text, but real apps need clean typed data. The library that fixes that is pydantic, and you will import it in almost every AI project you build. If you're coming from TypeScript, pydantic is basically Zod for Python. Pair it with a library called instructor, and the model is forced to return data that matches your schema. That one trick turns a language model into a reliable function. Once you can call a model, you'll want to chain calls together, give the model tools, and let it make decisions. That's what the orchestration frameworks are for, and this is where the ecosystem gets loud. LangChain is the big general purpose toolkit, and it's the fastest way to get an agent running. LangGraph, from the same team, is the engine underneath it. LangChain's own agents are actually built on LangGraph, and you reach for it directly when you want real control over agents that loop, branch, and remember. Llama Index is the one to reach for when your whole job is answering questions over your own documents. Beyond those, you'll hear about Crew AI for teams of agents, pydantic AI if you already live in pydantic, and DSPy for optimizing prompts automatically. Start with one, don't collect them all. Under all the AI libraries sits the plain data and math layer that Python has had for years. NumPy is the big one. It handles arrays and vector math, and here's the part that clicks for a lot of people. An embedding is just a NumPy array of numbers. Pandas is for tables of data, loading it, cleaning it, looking at it, and scikit-learn gives you the classic machine learning tools that still come in handy around LLM work. You won't touch these every day, but you'll be glad they're there. Models don't read words, they read tokens. TickToken is the little library that counts tokens the way the models do, which is how you estimate cost and size your inputs before you ever hit the API. When you want to turn text into embeddings yourself, Sentence Transformers does it in one line, locally, and for free. And Transformers, from Hugging Face, is the front door to thousands of open models you can run on your own machine. Once you have embeddings, you need somewhere to put them and a way to search them. That's a vector database. And this is one of the most crowded corners of the whole ecosystem. If you're just learning, start with ChromaDB. It runs locally with almost no setup. If you already have a Postgres database, pgvector lets you do vector search right inside it. No new service to run. For production, you'll hear about Qdrant, Pinecone, and Weaviate. That's the self-host versus managed decision. And Face is a fast in-memory search library when you don't want a server at all. Same job, 4 different trade-offs. Before a model can answer questions about your PDFs, somebody has to turn those messy files into clean text. That's ingestion, and it's the unglamorous half of every RAG project. PyPDF pulls text out of PDFs, unstructured, handles a whole pile of formats in one library, PDFs, web pages, Word docs, and Beautiful Soup pulls content out of HTML. Get this step right and everything downstream gets easier. At some point, your AI code has to become something other people can actually use. For that, the default is Fast API. It's a modern web framework that's fast, typed with pydantic, and it writes your API docs for you. Fast API runs on a server called UVcorn, and you'll talk to other services with HTTPX. And if you just want a quick interface to show something off, Streamlit or Grad.io give you a working UI with almost no front-end code. Model APIs are slow, and sometimes they fail. If you call them one at a time, your app crawls. Async I/O, which is built into Python, lets you fire off many calls at once and wait for them together. And because these APIs do fail, you wrap the calls with a library called Tenacity. It retries automatically with sensible backoff, so a rate limit or a hiccup doesn't take down your whole job. When it's time to deploy, most of the AI world lives on AWS, and the library that talks to AWS is Boto 3. S3, Lambda, databases, it's all Boto 3. This is bread and butter for shipping. If you're running your code in a Lambda function, AWS Lambda Power Tools gives you logging and tracing built for that world. And for loading your config and secrets cleanly, python.environment keeps your API keys out of your code. Not everything has to go through an API. Sometimes you want a model running on your own machine for privacy, for cost, or just to tinker. The easiest way in is Ollama. If you want to go deeper, Llama CPP Python runs the small quantized models directly, and when you're actually serving a local model to real traffic, VLLM is the high throughput option. Most people never need the last two, but it's good to know the latter. Here's the part almost nobody teaches, and it's what separates a demo from a product. Once your app is live, you need to see what it's doing. LangSmith and LangFuse trace every model call, every prompt, every token, and you need to know if the output is any good. Libraries like Ragaz and DeepEval score your results with real metrics instead of a gut feeling. This is the boring, serious layer, and it's exactly where you build an edge. A few of these aren't AI libraries at all. They're the tools that make the whole thing pleasant to work in. The big one right now is UV, a package manager that's quickly becoming the default for new projects, replacing pip and poetry. And it is fast. Rough lints and format your code in one shot. PyTest runs your tests. And Typer with Rich turns a plain script into a polished command line tool. Small things, but they're the difference between a hobby project and something you're proud to ship. Okay, that was the full map. But you don't install all of it. So let me give you the short list by what you're actually trying to build. This is the part to screenshot. Just calling a model, Anthropic, Pydantic, and Python.environment. Doing RAG over your own docs to learn ChromaDB, sentence transformers, and PyPDF. Building an agent, LangGraph, Tenacity, and LangSmith. Shipping an API, Fast API, UVcorn, and HTTPX. Deploying to a Lambda, Boto 3 and AWS. Lambda Power Tools, running models locally, Ollama, find your row, install those, and ignore the rest until you need it. So here's the honest takeaway. You do not learn all of these. You learn Pydantic, one model SDK, and Fast API. Then you add exactly one library each time you hit a problem that needs it. That's how the whole ecosystem stops being scary and starts being a toolbox.